Welcome back to Daily Dose of Space. Today we are doing something a little different. Instead of focusing on a single news story, we're connecting two of the most fascinating things happening in astronomy right now. The newest updates on the Interstellar Comet, 3I/A TLAS, and the 30-year legacy of NASA and ESA's SOHO spacecraft, a mission that completely changed how we understand the Sun and the space environment around Earth. These two stories may sound unrelated. One is a frozen object from another star system. The other is our own star, blazing 150 million kilometers away. But when you put them together, they reveal something bigger: how comets, stars, and magnetic fields shape the invisible space weather that surrounds every planet, including Earth. And by the end of this video, you'll understand why scientists say that studying 3I/A TLAS today might help us understand the kinds of environments that planets could experience around other suns. So, let's begin. What 3I Atlas is doing right now. In late 2024, astronomers spotted something unusual moving through the outer solar system, an object on a hyperbolic orbit, meaning it wasn't bound to the Sun and would never return. That immediately raised eyebrows. This would be only the third confirmed interstellar object ever observed after Oumuamua in 2017 and Comet 2I/Borisov in 2019. Today, that object is officially known as 3I/A TLAS, and we've had weeks of new observations that show the object behaving far more dynamically than most scientists expected. Instead of a quiet, frozen chunk of ice drifting through space, Atlas appears to be pulsing, flaring, and releasing powerful jets of gas every 16 hours. Almost like a heartbeat. These pulses are likely caused by rotational heating, where sunlight warms different regions of the nucleus unevenly. As the object slowly spins, certain areas rapidly warm and release gas in bursts. But what makes Interstellar especially interesting is that the energy of these bursts seems surprisingly high for an object this small. Some astronomers suggest its structure might be fragile or patchy, like a cluster of loosely bound rubble from another solar system. Whether these outbursts continue or lead to fragmentation will tell us a lot about how comets behave around other stars. But more importantly for this video, Atlas gives us a window into how material behaves when exposed to changing stellar environments. And that brings us to the second part of our story, our own Sun. What we've learned about the Sun's temper. In December 2025, the joint NASA-ESA Spacecraft SOHO, the Solar and Heliospheric Observatory, quietly celebrated its 30th anniversary. This mission wasn't supposed to last more than a few years. Instead, it rewrote almost everything we know about the Sun. SOHO gave us the first long-term monitoring of the solar wind, the constant stream of charged particles blowing outward from the Sun. It revealed how the corona heats to millions of degrees, far hotter than the surface below it. And maybe, most importantly for Earth, SOHO made it possible to predict solar storms days before they hit us. It was SOHO that discovered thousands of sun-grazing comets, including many that disintegrated dramatically in the corona. It showed how fragile comet nuclei truly are, and how violently stellar radiation can tear apart small bodies. And now, 30 years later, astronomers are looking at objects like 3I/A TLAS through the same lens. What happens to small bodies when they pass through a star's environment? What does this tell us about solar systems, not just ours, but others across the galaxy? The link between Atlas and the Sun. So what connects an interstellar comet to our 30-year-old solar observatory? The answer is space weather. Space weather is everything that happens when a star interacts with the material around it. Dust, gas, planets, magnetic fields, asteroids, and comets. It's the invisible engine of the solar system, shaping atmospheres, carving out orbits, stripping planets of air, and destroying weak objects that get too close. What ATLAS is giving us right now is a real-time demonstration of how a small icy body reacts when entering a new environment. In this case, our sun's heliosphere, the enormous bubble of magnetic influence that surrounds the solar system. As ATLAS moves deeper inside it, it's exposed to increasing solar radiation, solar wind pressure, and magnetic turbulence. SOHO, for decades, mapped exactly how these forces behave. So now, every time ATLAS erupts, pulses, or releases jets, scientists can compare it to SOHO's long-term data on solar activity. They can predict when the comet should flare, when it should remain stable, and whether a solar storm could destabilize its surface. In other words, ATLAS is not just a comet. It's a test object entering a laboratory we've studied for 30 years. What this means for planets around other stars. This isn't just about a comet. The real scientific treasure here is understanding how star systems behave across the galaxy. If our sun can destabilize an interstellar comet in predictable ways, then other stars, especially young or active ones, could absolutely reshape their planetary systems. Space weather controls how fast atmospheres are lost, how habitable zones shift, how icy bodies deliver water, how radiation shapes the chemistry of new planets. ATLAS gives us a sample from another star, reacting to our solar conditions. SOHO gives us a 30-year record of how our solar environment behaves. Put together, they form a blueprint. How does a star sculpt everything around it? How universal is this process? Can other solar systems look wildly different from ours, or surprisingly similar? ATLAS's current behavior suggests the kind of stress small objects experience near any star. Some systems might be far harsher than ours. Some might be gentle. And this immediately connects to one of astronomy's biggest unsolved questions. What makes a planetary system stable enough for life? Why this moment is important. Right now, literally this month, astronomers are watching an interstellar object pass through a stellar environment we understand better than any other. It's a rare chance to compare theory with reality. Will ATLAS fragment? Will the pulses intensify? Will the jets weaken as it rotates away from sunlight? Will solar storms accelerate the erosion? No one knows yet, and that's exactly why this moment matters. ATLAS gives us a once-in-a-generation opportunity to watch an object from another world respond to our sun, while SOHO's legacy provides the scientific framework to interpret what we see. This is what astronomy looks like when news and deep science merge. A comet from another star, helping us understand the universal rules of space weather.